Now we're going to begin a little bit of a study into circles and some of the related lines and segments to circles. First of all, just to remind you about a little some of the terminology. When we talk about a circle, and then here I've got a circle. It's centered here at C. Let me go ahead and name it. Let's name it this way. Let's name it a little circle with a dot and C. Okay, that's how we'll denote that circle. A circle is a set of points. It's the set of all points that are equal distant from a center point. So, for example, in this circle, we've got the center point and we've got the distance here. Now, this distance, remember, is called the radius. Okay, so that's one little segment that we're going to talk about, the radius. Now, there's another segment, another type of segment, and it's called a chord. So let's suppose I've got a point here. I go over here to another point, and I've got a little segment there. This segment is called a chord. It's a segment that touches the circle in 2 points. Okay, it's inside the circle. Now, we could have a line that just passes through the circle, like this. Okay. Now notice that line passes through the circle. It doesn't begin and end on the circle. We call this a secant. Okay, this is a secant. It touches the circle in 2 points, and it just keeps on going forever. Now, there's a class of line that touches the circle in exactly 1 point. Okay, like this. Touches the circle in exactly 1 point, and we call this a tangent. Okay, this is a tangent line. Okay, touches the circle in exactly 1 point. Okay, so that's just some terminology. Now, circles, let's suppose you have a couple of circles in a plane. Those circles may intersect, or they may not. But here are the possibilities. They could intersect exactly at 1 point. They could be tangent to each other at exactly 1 point. They could intersect at 2 points. Or they don't have to intersect at all. So I've got some examples here to show you. Here's an example of where we have 2 circles intersecting in 2 points, of course. Now, as far as the single point of intersection, notice you can have one circle inside another, like this one. Okay. You could have the circles outside, like this one and this one, that intersect there at this external. They are externally tangent. We say this is internally tangent. And then you have circles that don't intersect at all. Maybe you have this situation. Those circles don't intersect at all. And then you look at this one. These circles don't intersect at all either. However, these are special types of circles. They share a center point. We say circles that share a center point are concentric circles. So those are concentric circles. Okay, terminology. More terminology. We want to talk about common tangents. If you look at parts A and B, here you have 2 circles and there are 2 tangents. There's tangent L and tangent K. Notice both of those lines touch both of those circles. They're tangent to both circles. Now here's the deal. Notice if I connect circle C to circle D with this line segment, notice my tangents cross that line segment. They intersect at that, and they have an intersection on that line segment. For that reason, we say that those tangents are internal. Okay? So those common tangents are internal. So we would just say L and K are common internal tangents. Now, notice over here on B, M and N do not intersect AB. So we say those are common external tangents. Okay, now, look at this. So let's just kind of tie everything together, look at some basics here. Here we have two circles. They have, an internal, they are internally tangent. They touch at this point right here. Notice we've got circle A and its radius. Let's see what its radius is. 1, 2, 3, 4. Radius is 4. We've got circle B and its radius is 1, 2, 3. And these are not concentric circles. These are just circles. One circle is interior to the other, and they have a tangent right here. Okay, so this green line here is a tangent. Okay, so that's just some basics. Now, let's suppose that we have a circle and we draw a tangent. Here's the thing that happens. Here's a couple of things we know. Let's look at this theorem 10.1. If a line is tangent to a circle, then it is perpendicular to the radius. Okay, so you know that right away. If you're told that you have a tangent to a circle, then you know that it makes a perpendicular to the radius. Okay, so that's very important. Likewise, if a line is perpendicular to the radius, then it's a tangent. Okay? So it goes both ways. Okay? So see this, if in a plane, if a line is perpendicular to the radius of a circle at its endpoint of the circle, then the line is tangent to the circle. Yeah. Okay? So that's a very important thing. Remember, tangents form 90 degrees with the radius. Very important point. So let's suppose that we've got a tangent. Let's suppose that this line here, it goes on forever. And let's suppose that this line BC is tangent to this circle. Well, we want to find out what the radius of the circle is. Well, we know this is 90 degrees here. Using Pythagorean theorem, we have this. We have 16 squared plus r squared equals the hypotenuse squared. Well, the hypotenuse is r plus 8. R plus 8. So Pythagorean theorem tells us this. Knowing that BC is a tangent tells us, okay, this 90 degrees, it's a right triangle. So now we have this. We have, just working this out, we've got 16 squared, which is 256, okay, plus r squared is equal to, now I want to multiply this out. I get r squared plus 16r plus 64. Yeah, like that. Now, notice that these r squareds are going to cancel. And what I can do is I can take 256 minus 64, and I get 192 equals 16r. Okay? See, I just brought this over to the other side. And now divide by 16, and I get 12. So r equals 12. That's the radius. So see, that's how we can use that bit of information. If we know that the tangents form a right angle with the radius, we can work problems like that. Now, the next big idea here. Okay, so if two segments from the same exterior point are tangent to the circle, then they are congruent. Another really big idea. So notice, here's this same exterior point here. Here's a point of tangency. Here's a point of tangency. So we know right away that this segment here is congruent to this one. Okay. Now, you may wonder, well, how do we know that? Well, notice that this is 90 degrees here. This is 90 degrees here. And then we've got this thing up here. Okay. Okay. So we've got two triangles here. We've got this triangle and this triangle, and they happen to be congruent by hypotenuse leg. Ah, well, that means the corresponding sides are congruent. Yeah, there you go. So let's see how we can utilize that. Let's suppose we know that AD and AB are tangent to this circle, and we want to find x. Well, we know that x squared plus 2 is equal to 11. That means that x squared is equal to 9. That means that x is equal to 3. Yeah, so there we've found x. So those are the big ideas that, there's some terminology here, but the big ideas. Theorem 10.3. Tangents coming from the same external point are going to create congruent segments. And also, tangents form right angles with the radius. They form a right angle with the radius. Those are the two big ideas.